Okay, so 6-3 exponential functions. We want to first evaluate these expressions. These can be done by hand or with the calculator. Okay, I'll try to show you both. Shouldn't take too long. 4 squared. Okay, I think we can all do that one. 4 squared, we just do 4 times 4. Okay, which will give us 16. We can crunch that in the calculator. Now, 8 to the 2/3 power may not be very familiar. What this means, the bottom number, we're taking that root of 8, and the top number, we're raising it to that power. So this means if I do a root symbol, the bottom number is the root. We're taking the cube root of 8, and we're squaring it. You can do 8 squared first and then cube root, or you can do cube root. You can do it like this. You can do cube root of 8, and then you can square it. Both of these will give you the same result. I like to try to make it smaller first. I would do this. Cube root of 8 is 2, and then this gives you 2 squared, which is 4. If you do it this way, you get 8 squared is 64, and then the cube root of 64 is 4. Either way, you get 4. So let me show you that one. Let's go calculator. First, I'm going to show you 4 squared. Okay, you can just type it in. You get 4 squared 16. If you want to do 8 to the 2/3 power, what you need to do, 8. Now, if you have the 84, it will show you different format, but the 83, I have to do raised, and I have to do this in parentheses. 2 divided by 3. So this is 8 raised to the 2/3 power. And you see we get 4. You can also do math, not second, we're going to go to math. You see this cube root right here, we can go option 4. And kind of like I was showing you here, if you do the cube root of 64, you also get 4. Okay, so you can do it multiple ways. And then this third one, properties of exponents, are what you want to remember from that table. I like for you to see what's going on. So think of this as like 1 times 3. 1 times 3. This 3 has a negative exponent, which is unhappy, and you want to make it happy. So right now it's negative. It's happy when it's positive. So to make it positive, this 3 is going to get moved to the opposite location, and then that makes this exponent happy. And then what's left is the 1. The 1 did not have the negative exponent, only the 3. So whatever has a negative exponent gets moved. If it was negative on the bottom, you would just move it up, and then it would be happy. Then from here, we can do 1, and then 3 cubed is 3 times 3 times 3, which just gives us 1 over 27. Okay, so we get 16, 4, and 1 over 27. Now we're going to show you how to do this one in the calculator as well. So I'm going to pull that calculator back up. I'm going to type it just like this. 3, you're going to raise it. Do not do the minus sign. If you want to do negative, you have to do the 1 below 3. So you got to do negative 3. 3 raised to the negative 3rd power. When you do that, you get this decimal. Problem is, we want it as a integer or simplified fraction. So you can hit math, enter, and it will convert it to a fraction for you. Okay, so let's go ahead and input these. The first one, we got 16. Next, we get 4. And then we get 1 over 27. Okay, number 2, I didn't look at all the definitions, but let's talk about this. It says, decide whether the following statement is true. The graphs of y equals 3 to the x power and y equals 1/3 to the x power are identical. Well, I hope you can tell that just by looking at these equations, these are not the same. Also, in passing, in the overview, we did talk about the difference. If you have a number bigger than 1 right here, you're going to get exponential growth. Your graph is going to be going up. Okay. If you have some number less than 1 but still greater than 0, so it has to be positive, you're going to get exponential decay. So it's just going to flip that graph. So these two graphs, if they were on the same graph, would look something like this. The y equal 3x would go up like this. And then the other one would just come down and they would cross right there. This would be y equal 1 over 3 to the x. It would just be mirror images, reciprocals, inverses of each other. Not really inverses, but just a reflection across the y-axis is what you see. So these are not identical. You can graph it as well. Let's go ahead and do that. Y equal, we'll say 3 raised to the x. All right, and we're going to go down, and then in parentheses, we're going to do 1 divided by 3. Always need to put fractions in parentheses in this older calculator. And then we're going to raise that to the x, and then graph it. So here's the first one, and then here's the second one, right there. And you get those two, and they're not identical. You can see that. Okay, so we're going to say it's false that these are identical.